Hey guys.
Hello, everybody.
Hello.
So today is Friday the 17th, so we're going to cover day 16 and 17 and answers for day 7.
Day 7.
Day 7, sorry. Moving quite along. How you guys all doing so far?
Day 6. I asked a little bit.
Wow.
Every other day I've been successful.
Yeah, I think I have left over part 2 of 14 and 15, but I think 15 I only got because there was a bug in my code.
My day 15 part 2 code took about 10 minutes to run and finally spit out an answer. Before that, I kept getting a bunch of maximum stack exceeded errors. So day 15 took me.
Sounds like you're brute forcing it.
Day 15 part 2 took me a while.
I was thinking for day 15 to try to not brute force it after all the stuff I went through for day 6, but I don't know if I can. I'm smart to think of a way around it. I might have to do the brute force method. We'll see.
I read up on some of the pathfinding algorithms, but I just
you did?
actually implemented a very lazy version of one of them.
Like extra?
Yeah. I kept, actually, the only thing that I added after reading about that dextrose algorithm was I added just one array to keep track of things. But most of my code I had the same beforehand, didn't have to modify.
Well, Dexter uses, I think, a visited array.
Yeah, that's the only thing I added.
No,
that allowed my code to run, at least.
Yeah.
Before adding that, it just took way too long. The fans would spin up and nothing would happen.
Yeah. Yeah, I used a heat map. Something I had used in the past, but it wasn't working with this one.
Yeah.
But anyways, it's we're getting ahead of ourselves. I think everybody else is here to read about the recent ones and an answer for a past one. So we'll have plenty of time to talk about day 14 and 15. Anyhow, let's dive right in. So we are now looking at
16 and 17.
And 17. So I will share my screen.
We're getting close to the end.
Wow. I will not share my screen because I don't have it up yet. Just give me 1 second. We are on 7. Oops, that's not what it is. Now I will share my screen. Yeah.
Yep.
So there we go. The treachery of whales. Who wants to read this one? Well, actually, no, we're not reading the whole thing. We're just gonna go. Let's just go cover it because some of these start getting long and we're covering it twice.
Well, this is the one that we're doing answers for later. We're gonna read day 16. Right.
What's that?
You're showing day 7 right now. That's the one we're doing answers for later.
Yeah. Sure,
we gotta cover day 16 first.
Yes. Yes. The mind boggles the ineptitude of it. Oh, but it's the same screen. I'm sorry, I just got to work, so my brain is not. It's still on the bike somewhere 3 miles away. So we're going for day 16 first. Yep. Day 16. The Packet Decoder. Who wants to cover this one?
Okay, I will cover this one.
Thank you, Farouk.
Yeah, it's actually my first time reading day 16 now.
Okay.
Oh.
Yeah, didn't try it yet. As you leave the cave and reach open waters, you receive a transmission from the elves back on the ship. The transmission was sent using the Recency Interchange Transmission System, BITS, a method of packing numeric expressions into binary sequence. Right. Your submarine's computer has saved the transmission in hexadecimal, your puzzle input. The first step of decoding the message is to convert the hexadecimal representation into binary. Each character of hexadecimal corresponds to 4 bits of binary data. So we have hexadecimal matching binary pairs from 0 to F until representation of F in binary. So BITS transmission contains a single packet at its outermost layer, which itself contains many other packets. So the BITS transmission contains a single packet at its outermost layer, which contains many other packets. The hexadecimal representation of this packet might encode a few extra 0 bits at the end. These are not part of the transmission and should be ignored. Right? Every packet begins with a standard header. The first 3 bits encode the packet version, and the next 3 bits encode the packet type ID. These 2 values are numbers, and all numbers encoded in any packet are represented as binary with the most significant bit first. For example, a version encoded as a binary sequence 100 represents the number 4. Okay. Packets with type ID 4 represent a literal value. Literal value packets encode a single binary number. To do this, the binary is padded with leading zeros until its length is a multiple of 4 bits, and then it's broken into groups of 4 bits. Each group is prefixed by a 1 bit, except the last group, which is prefixed by a 0 bit. These groups of 5 bits immediately follow the packet header. For example, the hexadecimal string D2FE28 becomes, we have the binary representation first, and after that, I think we have the BCIT transmission value. Below, each bit is a label indicating its purpose. The 3 bits labeled V110 are the packet version 6. Yeah, so we have binary value representing 6.
110 in decimal is 6. If you convert the binary value 110 to decimal, you get 6.
Yeah, so we have that represents a version value, right? Packet version. So 3 bits labeled T10 are the packet type ID 4, which means the packet is a literal value. The 5 bits labeled A10110 start with a 1, not the last group. Keep reading, and contain the first 4 bits of the number 1000. The 5 bits labeled B11110 start with a 1, not the last group, and contain 4 more bits of the number 110. The 5 bits labeled C1000101 start with a 0, last group, end of packet, and contains the last 4 bits of the number 1010. The 3 labeled 0 bits at the end are extra due to the hexadecimal representation and should be ignored. Right, so this packet represents a literal value with binary representation 10 multiple binary data, which is 2021 in decimal. Every other type of packet, any packet with a type ID other than 4 represent an operator that performs some calculation on one or more subpackets contained within. Right now, the specific operations are not important. Focus on parsing the hierarchy of subpackets. An operator packet contains 1 or more packets. To indicate which subsequent binary data represent its subpackets, an operator packet can use one of 2 modes indicated by the bit immediately after the packet header. This is called the length type ID. All right. It's the length type ID. It's the length.
Another page. We're not there yet.
This is a lot
If
of
the length type ID, if the length type ID is 0, then the next 15 bits are a number that represent the total length in bits of the subpackets contained by this packet. If the length type ID is 1, then the next 11 bits are a number that represents a number of subpackets immediately contained by this packet. Let me reread this one. If the length type ID is 0, so probably we need to get the length type ID after getting the subpacket length or the binary data length. If the length type ID is 0, then the next 15 bits are a number that represents the total length in bits of the subpackets contained by this packet. If the length type ID is 1, Since the next 11 bits are numbers that represent the number of sub-packets immediately contained by this packet. Finally, after the length type ID bit and 15-bit or 11-bit field, the sub-packets appear. Right, so first we get the length type ID, and after finding if it's 1 or 0, it determines the length of sub-packets after that digit. And after this length of sub-packets, we have the sub-packets themselves, probably. For example, here is an operator packet, hexadecimal string 38006F, hexadecimal string with length type ID 0 that contains 2 sub-packets. So in this hexadecimal string, we have a length type ID of 0 that contains 2 sub-packets. As below, we have the 2 sub-packets. Okay, so in the letters, characters.
Below describes what you're looking at.
So the 3 bits labeled V are the packet version 1, this 001, and the 3 bits labeled T110 are the packet type ID 6, which means the packet is an operator. The bit labeled I, yeah, probably that one, is the length type ID, which indicates that the length is a 15-bit number representing the number of bits in the sub-packets. Okay, the 15 bits labeled L, so we have the characters L from starting at 0 until 011 contains the length of the sub-packets in bits 27. The 11 bits labeled A contains the first sub-packet. A literal value represents the number 10. The 16 bits labeled B contains the second sub-packet, a literal value representing the number 20. After reading 11 and 16 bits of sub-packet data, the total length indicated in L27 is reached, and so parsing of this packet stops.
And remember, each sub-packet also has its headers too. Each
So
sub-packet will have the 3 bits for the version and the 3 bits for the type. And
okay, so after reading 11 and 16 bits of sub-packet data, the total length indicated in L27 is reached, and so parsing of this packet stops. Right. So after parsing B, we stop there. As another example, is an operator packet, hexadecimal string. All right, we have hexadecimal string with length type ID 1 that contains 3 sub-packets. So probably after parsing the hexadecimal data based on the first described algorithm or approach, we get this parsed value in binary and also in letters, right? And we have to parse this binary and letters itself in order to get the lengths.
The letters are just there just for your clarity as part of instruction.
Oh, we only get the binary data then, right?
Well, you only get the hexadecimal.
yeah, you get the hex, you have to convert it to binary.
Yeah, we have to parse it into binary, and then we will work with the binary
Right.
to get it. All right.
So all these letters down here are just for, just for the explanation of how to read that binary number.
Okay.
Can I give a small tip about when converting it to binary?
Let's get through this reading. There's still
Let's get through the explanation first. So we have another example, and we have an operator packet in this example, I think, with a type ID 1 that contains 3 sub-packets. 3 bits labeled V once at the beginning are the packet version 7, and 3 bits labeled T after that are the packet type ID 3, which means the packet is an operator. So the bit labeled I1 is length type ID, which indicates that the length is an 11-bit number, okay, representing the number of sub-packets. So we have 11 sub-packets in this string. So 11 bits labeled.
Oh, but 11 bits.
11 bits
Yeah, 11 bits.
the 11-bit label L that contains a number of subpackets 3. So we have the number of subpackets with L. The 11 bits label A contains the first subpacket. Oh, all right. So the bit labeled I, num1 is the length type I, which means that the length 11-bit number represents the number of subpackets. So 11 bits labeled L represents a subpacket amount number, right? 1 or 2, 3. So because that L represents the 3 in decimal. So the 11 bits, 11 bits labeled A contains the first subpacket. The 11 bits labeled B contains the second subpacket, a literal value representing 2. And 11 bits labeled C contains the third subpacket, a literal value representing number 2. So we have the packets 1, 2, 3 in decimal. After reading 3 complete subpackets, the number of subpackets indicated in L3 is reached. All right, and so parsing of this packet stops. Yeah. This part I didn't understand. After reading 3 complete subpackets, the number of subpackets indicated in L3 is reached. And so parsing of this packet stops.
The I value or the L value told us that there were 3 subpackets within that outer packet. So we've already read 3 subpackets. We finished the 3rd subpacket. So we know that the outer packet is finished.
Okay. Thank you.
We read the outer packet and the 3 inner packets. So that packet is now finished.
In L, I thought it was the C packet indicated because the C also represents 3, right? But L, the first indicator, all right? So after reaching 3, we can stop the parsing after the C's, and we can ignore the last 5 zeros at the end of the binary. For now, parse the hierarchy of the packets throughout the transmission and add up all of the version numbers. Here are a few more examples of hexadecimal encoded transmission. 8A004A80 represents an operator packet version 4, which contains an operator packet version 1, which contains an operator packet version 5, which contains a literal value version 6. This packet has a version number of 16. Okay, so you have to add up all the version numbers indicated in that string by the subpackets or any packet inside that string, I think, not only subpackets inside the subpacket. So we have another example, 62.008.00016.11.56.2C88.02.11.8E34 represents an operator packet version 3, which contains 2 subpackets. Each subpacket is an operator packet that contains 2 literal values. This packet has a version sum of 12. So we have an operator packet with version 3, which contains 2 subpackets. Each subpacket is an operator packet which contains 2 literal values. All right, so we have 4 and 8. Each subpacket that contains 2 literal values. So we have 2 in each of them, right? We have 4 and 8. 4, 4, 8. So this should sum up to 11, no?
Or which one?
Second example, we represent an operator packet version 3, which contains 2 subpackets.
Yeah, but it doesn't tell you what the literals are. Or it doesn't tell you what the versions are. So the versions, remember, can be any number. So these 2 subpackets, or rather these 3 packets, the outer packet and the 2 subpackets all have a version sum of 12.
But how did the example end up is 12 then?
Well, we'll break one out. I'll break that one out later, but let's keep going. So just so we get to the end of instructions, because there's a lot of confusion on this one, even for me.
So we have that third example has the structure as a previous example, but the outermost packet uses a different length type ID. this packet has a version sum of 23. And the last example is an operator packet that contains an operator packet that contains an operator packet that contains parameter values. Because a version sum of 31. Okay. All right. You can see the end.
You picked the right day.
I feel like that's an
Oh, it's a
accomplishment
structure.
just reading it. This is a long, dense question.
Yeah.
Decode the structure of your hexadecimal encode. Decode the structure of your hexadecimal encoded BITS transmission. What do you get if you add up the version numbers in your packets? I think I took this one because I had not read it before, and none. Everyone who had seen this before did not want to volunteer.
Yeah, this one, I mean, I could kind of see what the guy was going for. I wasn't named Eric Witzel or whatever, because I mean, every year he does puzzles based on, you know, based on things that happen or that exist, and packets exist, and the way that packets are parsed is actually pretty true to this. But having to explain it, I'm impressed that he went through the entire, I guess, effort to put all this together. That's quite.
Is this similar to
Quite
how real
complex.
packets are read?
I would say it's even more complex.
Okay, of course.
Yeah, because this
But
is
each
like,
packet probably does have its own header, a version or something.
yeah.
Got the information bits at the beginning and then the data bits towards the end.
Well, I mean, he does you one favor in that he gives you one packet. It doesn't give you 20 packets and asks you to get the 17th one.
Yeah, but
Right.
that one packet he gives us might have 100 packets inside of it.
Sure.
Packets inside of packets inside of packets.
But you already know where the limits are. That's
Yeah.
my point. Versus like trying to pick a packet out in the middle of a stream of data. I think that's one challenge. The other thing is like some of these encodings, depending on the encoding, it may be, for example, big Indian, little Indian, where the binary numbers are reversed. There's a lot of weird things that happen with packet transmissions, but you know, now you get to appreciate a little bit about the complexity and actually the kind of like wonder of how transmissions actually work.
This is
On a lower level. This is not even the lowest level, but a lower level. But anyway, the whole idea is that there's like pieces of stuff, right? And pieces and pieces. Now, the interesting thing about the packets that he represents, which is true of most packets, is that there's nothing necessarily like when we do code, there's like a beginning bracket and an end bracket. So visually, you know where to stop processing a block.
yeah.
You don't get that here. You have to take it out of the packet. Before that block starts, it has to tell you where that block ends, either by the length or by telling you how many subpackets there are inside. And so then that's how you know, okay, this subpacket is done and it doesn't bleed into the next subpacket. So if you have a large packet of 2 subpackets and one of those subpackets has 3 subpackets, you know where to stop reading because there is no borders between these things. Right? There's no visual indicator at the end of the first subpacket that its subpackets are finished before it starts bleeding into the second subpacket. And so that's the kind of challenge, I think, of reading some of the stuff. But anyway, let's break one down. I think it'll be good for everyone to kind of see the madness of what's going on. Let's just start with the first one, because the first one, I think, is somewhat representative. So we take the first one. Can you see when I switch tabs?
I see your incognito tab.
Okay, so we have online, let's say, what is this, hexadecimal?
To binary.
No, to binary string. Which is different from binary bytes.
Oh, you do it online, cool.
Yeah, you could do the whole thing online if you wanted. I don't need no sticking tools. All right, so there's the binary output. Yeah.
One thing I noticed when using JavaScript to convert from hex to binary, you can do, so I can parse the hex one with base 16, and then I can do two string with base 2 to get it into a binary. But I noticed that when I do that, oftentimes if there are zeros at the beginning, it cuts those off. If the leading numbers are zeros, it removes those when I do 2 string.
Okay.
So I noticed that I had to consider that, and I had to make sure that I'm adding in those zeros back to the beginning of the string if they got cut
Yeah.
off.
Yeah. So you know there's a fixed length. To the
Yeah, I
string.
know the length is going to be a multiple of 4 because each hexadecimal is 4 bits.
Yeah, but that is annoying. I think.
So it was quite annoying. I just had to add in an extra little bit of code to make sure that my code is a multiple of 4, or
Yeah.
my length of my string.
Well, how do you know which multiple of 4?
Just the nearest multiple. I'll just well, no, if it's not a multiple of 4, all I have to do is just add a 0.
Yeah.
Add zeros
But-
until it is a multiple of 4.
Or, I mean, the other alternative is they give you a nice table at the beginning.
You could do that too. That's a lot.
You can use a table to
Yeah.
do the translations, and I think that's what I ended up doing.
That's so much more code.
You'd be surprised. It's not actually too bad. Yeah. But anyway, so we have this into binary, right? This giant string that was that first example, spread out.
Okay.
So we start. So the first 3 we know is going to be the version. Good. So we're just going to go from left to right. The second 3 is going to be the version number, or not the version,
Type.
the
Type ID.
Yeah. So this one.
Type ID, ID.
Right, and 2 is not 4 because the only one that's special is the 4, the literal.
So it's going to be an operator.
So it's going to be an operator. And then we have a 1, which tells us it's going to be length type.
11 or yeah.
It's going to be the number of subpackets.
Okay.
The next one's going to tell, the next 11 bits will tell the number of subpackets.
Okay, so the next 11 bits will tell us the number of subpackets, right? So that's right here. So the length ID is 1, next 11 bits, the number of subpackets. So let's count from there. 11 bits, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 1. So there's 1 subpacket in this.
Okay.
Okay, and so that, we keep that in mind.
And
So
then-
now the subpacket starts.
yeah.
Okay, we've established the header of this packet. There's only 1 subpacket. Okay, so start out, and we got another version ID of 1. So now we got, so far we have this version, which is 4, right? And then we have this one, which is 1. So far we have 5 for our version sum. Because at the end of it all, we want the version numbers, right?
Yeah.
Okay, so this is a 1. Type is 2.
So another
Operator with another, number of
subpackets.
subpackets. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1 subpacket. So now we have a subpacket, or we have a subpacket within a packet. So far, our version total is 1. So let's start our subpacket of the subpacket of a subpacket. First one is now the version numbers. So it's 5. So 5 plus 5 is 10, right? We have 5 so far. The next 3 are the ID. Again, it's 2.
Another operator.
Another operator because it's not a 4. This time we have a 0, which means the next 15 tell us how many subpackets there are,
Okay.
right? And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, right? And so 15, we have 3. Oh, we have how many? That's not right. That's too many. Oh, no, this is the number of bytes, a number of bits to read, right? And so we have 11, right? 8 plus 3.
Yeah.
So the next 8 bits are part of this subpacket. Okay, so let's read the other subpacket. The next subpacket we start out with is 6. So we have 15 so far. So right, 15 plus 6 is 21. At this point we can stop, but if you want to, because we really only need the total of subpackets, but we can keep going. This one has ID of 4, which means that it's a literal, and the literal value is going to be starting with a 0, which means that this is the last literal that we're going to be doing, and the literal itself is that, which is an F. or 7, 16, 17, 8, no,
27.
15, it's 15. And then the 3 are throwaways. Okay, so it should be 21, right? What was the example? Oh, 16, I think we added it wrong. So this one says a version pack 16. Let's go back and re-add. Somewhere I added it wrong. So there's 4. After the version packets, there was 4 plus 1, it's 5. After that linked packet, was this the packet version? Yes. 5 plus 5, right? So we had 10 so far.
Yeah, that's where we were. Then what was the last one?
The last
The
one,
last one was 6, I think.
was-
So I think we got 16. We just double added one.
Hold on a second. So that one was the, oops. No, I'm lost in the zeros and
We
ones.
gotta start over with the beginning again now.
No. Because we know that this was a linked packet and that the 11 should have been
Yeah.
1 because there's 1 sub packet. So
That's
it means
it.
that was the version. So that's not 5 though. Okay, let's start over. So there's 4. There's the type. There's the length.
And the number of subpackets.
Number of sub packets is 1. And there's my other version. So we have 4 and 1.
We're at 5.
Write this down somewhere. Okay, so we got 5, 4, and where was the 1? Is that the 1? Yeah, that's the 1.
Yeah.
Type was 2. Length is, or length ID is 1, and then then we got another 1, and then this is a 2 plus 1. Oh, it's a 3. What was that? That was here, right?
Yeah.
So 3. Type is 2. Length
This is 0
is
now.
length type is 0, which is number of packets, which is a
We go all the
1
way to
packet.
the 1011.
Oh, that's
So this
right,
is
that's right, that's
15
right,
this time,
15 for this
15.
time, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then after that, so length was 11, and this was my last packet version number, which is 6, right? 1, 0, 1, 4, and 2, 6.
Yeah.
It's still got a mistake. Now we only have 14, we should have 16.
All right. It's like not counting correctly in binary. I'm sure someone's out there being like, oh, you're an idiot. And then this is 2 and 1. That should be 3, right?
Yeah,
3.
is that the right place though? Yeah, that should be.
And then type 2. 1 for 15. 7, 8, 9, 10, 12, 13, 14, 15. Another version number of 101, which is 4 and 2. And then the 3, and then there's 1. So that should be it.
Are there leading zeros that got cut off? What's the total length of your string? Maybe leading zeros got cut.
Let's see. You have to find another website then.
For a character count?
On Windows, the calculator can convert hexadecimal to binary.
And what does the Windows say? I'm loading up.
Ah,
VS Code just
So
to,
that you know.
If there are leading zeros, then everything changes.
yeah, everything changes. Let's see how many characters we got. Oh, we got 72 characters. So a multiple of 4, it's possible.
Yeah, it is. So it should work. Then.
Yeah. 18. So we have the operator packet. We have the operator packet.
So
We have the
yeah,
operator packet.
so we can check. They told us the first operator packet had version 4. The second one had version 1 though. So that's where we messed up right there.
No, we had a version 1. We messed up on the second one. It was a 5
The
instead
next
of
one,
3.
version 5.
So they're saying that that was a 5 instead of a 3.
So that was, yeah.
Where was that? You know what I'm gonna do? So there's that. There's that whoa. There's that length ID. There's the packet header, right? That's the end of the header. So that's the beginning of another packet.
Oh,
This is what I
okay.
should have done in the beginning.
Yeah.
There's a header, there's a linked ID. There's the end of that header, right? In fact, since we can type into here, I want to just like break these out so I don't have to keep. Oh, I can even like do pagination. Ah, brilliant. Okay. So then we have this one.
But that's not fun.
That one, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Just this one, just that one. And that one is garbage.
But that doesn't match what they told us.
No, that's a 3. That's definitely a 3.
Is there a mistake in the sample?
I don't know. That's pretty infuriating.
4, 1, 3, 6.
Usually there's not mistakes in that code examples.
Unless we screwed up somewhere somehow.
I'm gonna check Reddit, see if anybody else.
All right, let's do another example and see if. But you guys get what we're doing here, right? Let's do the second one.
Yeah, I need to reread it because when I heard Farouk talking, like explaining the stuff,
Yeah.
I just heard bit, packet, sub-packet. So I was like, I have no idea what he's talking about.
All right, so here's another one. So this one's a little bit more complicated, but let's see if we can break it up. So there's the header. There's the type. It's not 4, so we have to get the linked ID, which is 1. Linked ID of 1, which means that 11 bits tells the number of subpackets. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, so there's 2 subpackets. All right, maybe. So you got 0, 0, 0. So then it's 0. So then it's the number of subpackets in the next 15. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Ooh, everything feels like it's 1 off. But let's keep going. So then this one. Yeah, I think everything is 1 up because that ends up being a giant number. That doesn't look right. Oh, but this is a type 4, so maybe that's okay. Yeah, that's okay. It's a type 4, which means that there's only one what should we call it, literal. And so then that should be completing that one. But this one says that there is a because it's sub length type of 0, it means that these are the number of bits that were used to describe it. We have 2 plus 4, which is 6. Let's see, 6, 4, 8.
20.
We're at 20?
That doesn't make sense.
No, 4, 8, 16, right? So 16 plus 4, 20. So 20 numbers.
Wait, 16 plus 6, so 22.
16 plus 6 is, yeah, so you're
So
right.
22, that makes sense.
Okay.
That's
that
enough
should
for
be
2.
about
That's
11,
enough for 2 literal values.
right?
So literal value, minimum length can be 11 bits.
Yeah, and so those are 11 bits. So those are the 2 subpackets that fulfill this subpacket envelope.
Yeah.
But it keeps going. Do we have to keep reading? Well, this subpacket is happy
But the
because
outer
we got our
subpacket is not.
22. The outer one, because we have 2 subpackets within there. So 2 subpackets.
Can you indent the subpackets maybe to show like a tree? No. Or can you just space it
Yeah,
a couple times?
space it.
Do like 2 spaces for that one, and then the other ones you can do like 4 spaces to show
Right.
it there.
Okay, so
Subpackets. Those are subpackets.
do it Python style.
Yeah. Oh, beautiful. Okay. Yeah, I think that's a little bit easier to visualize where the subpackets are,
Okay.
whose children they are.
So that one has 2 subpackets. This one has
22
subpackets.
bits worth of subpackets.
Yeah, 22 bits. So then we go back to having our normal subpackets. So there's that. With the one, so which means that we have 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is another one where there's potentially 2 subpackets. Let's get into the subpackets. We got 0, 100, and then 100 is a 4, right? So these are literal values. So we need to only look at the 0, which means that's the last one of this subpacket. So we go return on there. This one's got that value, that value. This one also is a 4 with leading as 0. So that's a subpacket and that's garbage. So then we add up all our version numbers and we have what? This one is a 3, right? 3. This one is a 0. This one is also a 0. This one is a 5. This one is a 1. This one is a 0. And 3. And a 3. And so it would be 11.
12. 12.
Oh, 12?
Oh.
Oh, yeah.
Yeah, 12.
12. Right. Okay,
Is
so
that what we
12.
were looking for?
Yeah,
Yay!
Oh, okay.
yeah.
What happened to that first one? Was that first one wrong?
I don't know, something happened with that first one. But anyways, regardless of the answer, this is the process that you can use. You can use. Obviously, I'm sure maybe there's another way of doing it, but this is one way to just kind of hack through it as you chop up the numbers to try to get the version numbers that you want.
It looks good to see it typed out like that, where you can see the
Yeah.
different subpackets.
Yeah, especially for me, when I read through the text, I was quite confused, but with the illustration you gave us, it makes the problem simpler.
Yeah, I think this will help me. For me, when I was trying to decode it, the part that really messed me up was the number of subpackets one. So the operator type where it tells you the number of subpackets, because if it tells you the length, then it's easy to know when to stop. But if it tells you the number of subpackets, then you got to figure out how long that actual subpacket is.
Right.
For me, that was a lot more complex.
You have to kind of you have to keep an eye out of like, oh, I still have this container that's waiting to be fulfilled.
Yeah.
And so like, oh, there's 4 children. Oh,
Yeah. And
let's try to go.
how deep is your tree?
I just keep reading until I hit 4 children, and then at the end of that 4th child, then I need to close this thing off and start another subpacket, maybe in the same level. And so, but I think the challenge for this one, like I said, it's not necessarily, I think, when I spoke with you yesterday, leaving, it's not necessarily the difficulty in the technology of it. There's no like, it's parsing, but just reading the thing and then wrapping your mind out of like what it all means. Because, part of the puzzle is that they just represent it as like this. And then they represent it like this, and you're just like, what?
And your actual input is just going to be a giant string of hexadecimal.
Right. And so, but taking the extra step of breaking it apart, at least mentally, will organize it and see the pattern a little bit easier.
Yeah.
All right. Anyways, we spent a lot of time on 16. Let's go to 17. I haven't actually seen 17 yet.
I skimmed through it. It seems fun.
Yeah,
Would you like me to read it?
sure, go for it.
All right, day 17, trick shot. You finally decode the elves' message. Hi, the message says. That giant message is just to say hi. Are these elves or trolls? Because they're trolling us for sure.
It's like you win the lottery. Here's your gold chocolate coin.
Well, anyways, you continue searching for the sleigh keys. Ahead of you is what appears to be a large ocean trench. Could the keys have fallen into it? You'd better send a probe to investigate. The probe launcher on your submarine can fire the probe with any integer velocity in the x forward and y upward or downward if negative directions. For example, an initial xy velocity like 0, 10 would fire the probe straight up, while an initial velocity like 10, -1 would fire the probe forward at a slight downward angle. Okay, so x is your horizontal. So if your initial x velocity is 0, that means it's not moving forward at all. And so in the first example, 0, 10, it's moving with a y velocity of 10. So it's just going straight up into the sky.
It's kind of like a first stage, no?
This one's different, but let's keep going. The probe's XY position starts at 0, 0. Then it will follow some trajectory by moving in steps. On each step, these changes occur in the following order. The probe's X position increases by its X velocity. Makes sense. The probe's Y position increases by its Y velocity. Okay, cool, yeah. Due to drag, the probe's X velocity changes by 1 toward the value 0. That is, it decreases by 1 if it is greater than 0, increases by 1 if it is less than 0, or does not change if it is already 0. Okay, so you can have a negative X velocity too, I guess. Interesting. So your X velocity is always going to go to 0 eventually. And due to gravity, the probe's Y velocity decreases by 1. Okay. So this thing's launching through the water. So eventually it's just going to stop.
Follow this like parabolic path.
Yeah. So it's not shooting through space where it's just going to go forever. It's shooting through water where eventually it's going to slow down and stop. Okay. So your X and Y velocities are changing every step. For the probe to successfully make it into the trench, the probe must be on some trajectory that causes it to be within a target area after any step. The submarine computer has already calculated this target area, your puzzle input. For example, target area, x equals 20 to 30, y equals 10 to -5. This target area means that you need to find initial XY velocity values such that after any step, the probe's X position is at least 20 and at most 30. And the probe's Y position is at least -10 and at most -5. Given this target area, one initial velocity that causes the probe to be within the target area after any step is 7, 2. All right, so we look here. It looks like you're shooting something into a basket. We're playing basketball.
I think I played something like this with cannons on an Atari.
Ah. Okay, so
Or like, was it like
my first
Angry
game,
Birds kind of like this too?
kind of. One of my first video games that I remember was on DOS called Tank Wars. It came on a floppy disk, and it was just you had this little tank that was a few pixels, and you had to shoot. You could adjust your angle and your velocity, and it would shoot, and you tried to hit all the other tanks.
Hey man, that's worms.
Yeah, it was a little less than worms, I think. Very cheap graphics. Anyways, let's look at this. So in this diagram, S is the probe's initial position, 0, 0. Okay, so we start at S, and then our initial velocity is 7, 2. So we're going to go to the right, so forward 7 places, and up 2. So we get to so our first step is going to be that first number symbol right up there where it's highlighted. And now our velocity, our X velocity is going to slow down. So it's going to go from 7 down to 6 now. So we're going to go 6 steps forward. And our Y velocity too is going to decrease by 1. So our Y velocity now is only 1. So we're going to go 1 step up. And next step, our X velocity again is going to decrease by 1. So now it's going to go 5. And our Y velocity is now at 0. So we're not going up or down on this step. We're just going forward 5. Next, our X velocity is decreasing again. So now it's going to be 4. We're going to go 4 steps forward. And our Y velocity is now negative. It's going to be -1. So we're going down 1. And the next one, we're gonna be at, I think our X velocity is now at 3, and our Y velocity is now -2. So we're gonna forward 3, down 2.
This is 4 actually. Because this, oh, this was 6. Oh, you know what? We're counting differently. Am I counting up to the under the hash, or are we counting beyond the hash?
I think I'm counting from the place in front of the hash to the next hash.
Okay, so let's say the S. So 1, 2, 3, 4, 5, 6, 7 brings me right under it.
Yeah, so that's where that.
And then this one, then 1, 2, 3,
6.
4, 5, 6 brings me right next
Yeah.
to it. And the next one, and the next one is 5, right?
Yeah.
1, 2, 3, 4,
5
5.
brings you there. Next one should be 4.
1, 2, 3, 4.
And next one is 3.
1, 2, 3. Gotcha.
Yeah.
Okay.
All right, so now after this one, we're gonna go, our X velocity is now 2, and our Y velocity should be -3, so we're going down 3.
So we're not actually approaching 0 with the Y. We're actually
Yeah, Y is
Keep
keeps,
falling.
that's right, Y keeps getting faster down, I guess.
the road
Okay, so you're not gonna stop
increases
ever.
by 1 without any kind of stop.
But the X will go to 0.
Yeah.
So our X, like in the last step there, our X value is only gonna be 1. So we're gonna 1 forward, and now we should go down 4.
Yeah.
Okay, and that puts us in the target area. So that was a successful shot. We made it into the target area. All right. All right, so they have another example too, that also reaches the target area with a different initial velocity. So this one starts with initial velocity 6, 3. And you can see, if you see at the end, the X velocity here does go to 0. It's at the end, it's just dropping straight down. But it does make it into the target area. Another one that works is initial velocity 9, 0. So this one's just shooting straight forward, but because of gravity, it's going to drop down. And it makes it into the target. But can you scroll down now? One initial velocity that doesn't cause the probe to be within the target area after any step is 17 and -4. So if you look at this one carefully, you notice it looks like the probe's going through the target area, right? But it doesn't actually land in the target area after any step. It has one step that right before the target area and another step after the target area. It has to be within the target area during the step. You can't just jump over the target area. That's not.
It's almost like it teleports.
Yeah.
Point to point. The question is, at any point, are you going to be teleporting onto the pad? Because this one looks like it
Think
just,
about it like that.
this one just
Yeah.
goes right through. And so it's almost like, oh, but it goes through the thing. But yeah, I guess if you consider the fact that it has to end, of each step, it has to end on that.
Or think of it like in chess, you have the knight character that moves in an L shape, but you can't kill things in the middle of your move. You can only kill things where you land.
Yeah.
So you have to land in the target area.
What
The
about the
probe
start?
is
Do
passed
they
through
keep
the
the
target
start?
area, but is never within it after any step. Instead, it continues down and to the right. Only the first few steps are shown.
Alexia, you have a question?
Yeah. Do they mention where do we start? Because I missed it.
We start at 0, 0.
We start at the, wherever the S is in this one, but typically 0, 0.
So they give you the coordinates for the target area, and they tell us we're going to start at 0, 0. But you can go up from 0, 0. You can go to like 0. I don't know.
The first one we didn't start at 0, 0. Yeah.
We went to like 7, -2 or something.
We didn't start at 0, 0. Those two.
No, we did.
So
Because remember, we went over by 7, then up 2.
Yeah, so
this
that-
is actually 0, 0.
S is 0, 0, but we can also have negative row values.
Okay.
Well, I guess here it'd be they call this a positive row value. So above S is Y value 1.
1.
Above S is Y value 2. Below S is Y value negative.
But don't think of this as like the only area that things happen in. This is
Yeah.
just a small, reduced screenshot of basically,
Mhm.
just infinite area, but S is supposed to be 0, 0.
Okay. So then it's extra. Okay. Okay.
Yeah, they just
Yeah.
cut off the rest of it.
Yeah.
I mean, this technically just keeps going anyways. It's just that at one point it stopped, so they stopped it there.
Hmm.
This one probably also continues to fall
All forever
forever, but they stopped it here because it fell
into
into
the
the area.
abyss.
But this one, just to give you the idea that you can pass through it but you really have to land on it on one of your turns in order for it to be valid. If you pass through it without landing on it, you might as well not keep going because it'll never hit.
Yeah. Well, let's continue. We didn't actually get to the overall question. What do we
Yeah.
have to answer yet?
Yeah.
So if you're going to fire a highly scientific probe out of a super cool probe launcher, you might as well do it with style. How can you make the probe go? So, sorry, how high can you make the probe go while still reaching the target area? Okay, so we want to just shoot it with the maximum height that we can. We're going to just launch it into the air and watch it crash back down. In the above example, using an initial velocity of 6,9 is the best you can do, causing the probe to reach a maximum Y position of 45. Any higher initial Y velocity causes the probe to overshoot the target area entirely. Find the initial velocity that causes the probe to reach the highest Y position and still eventually be within the target area after any step.
I'm assuming they want us to stay within the integers. They don't want us to go into floating.
That's what I'm thinking too. Yeah, it looks like it has to be an integer value. What is the highest Y position it reaches on this trajectory? Wow. So you have to find the highest Y position you can get to while still landing in the target area.
Yeah.
Okay.
Cool.
Well, this one's a lot easier to understand what it's asking than day 16. I appreciate that. I don't have to read this one 17 times just to figure it out.
Yeah.
It's still, yeah, it's good that Alexi mentioned that though about 0, not actually looking like 0 in these pictures, because it is essentially an infinite space.
Yeah.
You can go to the, you can go farther to the left, and there's one piece there. It's just 0, I guess, in relation to where your target area is.
Do you think in part 2 they are gonna involve the wind?
Or birds.
How many birds can you hit?
Or-
And still make it into the target area.
Or it could be like SpaceX. Maybe the platform will keep moving.
Oh man.
It cannot be wind because it's supposed to be underwater, I guess. Oh, maybe no, the submarine chute.
We're
And
trying to find the trench.
It could be a current.
yeah,
The wind is equivalent.
okay.
I can see like fish in the way that you have to dodge. Like
Fish to dodge.
there's a whale, you gotta go around the whale.
Maybe there's a hydrothermal vent that's actually pushing up. On the way.
Yeah.
Who
It's
knows?
gonna be like one single trajectory that succeeds.
Uh,
But anyways, with this one, there is one single initial velocity or initial trajectory that will cause you to land in the target area and get the highest maximum Y value.
Okay, cool.
Any more questions?
We spent an hour on questions today.
Day 16 was miserable to read through.
I forgot how long it was, but that was, yeah.
Thank you again for suffering that with us.
I didn't know it was that long.
Well,
So
thank you for sticking through. I appreciate it. I'm glad I didn't have to read that one with all the 110110.
All right, so that concludes the questions for today. Good luck. Let's go through the answers that we have for day 7. Who wants to start? Well, let's just go over the question first, I guess, right?
Yeah, I guess we do.
Review the question. Let's see, let's go back to there. Day 7 was the treachery of Wales. Not the location in the UK, but the mammal in the water. So this is about
the crab submarine.
it's about crab submarines, right? Because they're all over the place, but you want to unite them in your powers of, I don't know, crab sorcery. Somehow you convince all them to channel all their streams together, or at least go on a nice grid to a particular location. And, you know, they're all scattered about, and you have to try to calculate what is the best, cheapest, most efficient place for them to all to get together with the least amount of fuel, basically, for them all to meet at one spot so they can, you know, join their streams in the Ghostbuster sense. And so the question is, how much fuel must they spend to align to that least fuel position?
Okay.
And now, fortunately, these are just horizontal positions, but somehow they're all in this
Yeah.
two-dimensional line, not like three-dimensionally spread out. So,
So you're gonna have like crabs on top of crabs?
yeah,
They're gonna
man,
be stacking up?
crabs all the way.
All right, well, I found a funny picture that I thought was relevant to this one. Well, it
Okay.
was made exactly because of this question.
Well, do share.
Let me share this. I thought it was funny. It made me laugh a little bit. Can you see?
Oh,
I bet he's thinking about other women. Why would crab submarines only go sideways? That guy's definitely doing advent of code in his sleep.
Yeah, I can relate.
Yeah.
I can relate. There have been probably times where I could probably spending thinking of things more important than the crab submarine puzzle, but I was thinking about it.
Or Dumbo octopuses. I still don't figure it out. Why would you turn off your light? Why would you turn off your light?
Why are they flashing?
Spend time to measure your light energy. And you want
Why are
to
these
find
people
the
octopuses
keys.
flashing? Oh, should I go ahead and share my code then?
Yeah, good.
All right, let's get to it. I did it in JavaScript as always. Let's see.
Okay.
All right, can you see my code? Well,
Is
my
your
VS
screen-
code.
Yeah, your
Let
folder.
me open up day 7. So here was the sample input I worked with. And my real input was a lot longer. I'm scrolling. There's a lot of crabs.
Oh, looks like.
So remember this input,
795.
this input shows the initial position of all the crabs, right? So I need to figure out where I can line up those crabs with the pretty much the most efficient way, the most efficient place to line them all up. All right, so like always, I import my file and split it up. And I wanted each of those values to be a number. So I mapped them all to a number now. So I have just an array of numbers that I'm going to be going through. Well, I wanted to figure out how much do I actually have to loop. So I went ahead and sorted my array of crabs so that I could get the minimum and the maximum values for their positions.
Okay, forget the range of the positions.
Yeah, I want to get, the range. So which crab, there's probably one crab at 0 or 1, and probably the last crab, looking through my input, I saw like 1,700 something. And then there's everything in between, I'm sure. So now I set an initial kind of counter variable called least to find the path or the location that has the least energy, the least amount of fuel usage. And I just set that to an arbitrarily large number to start, knowing that it's going to be way higher than the final answer because it's going to get overwritten with smaller values as my script runs. Next, I'm going to capture the length of my array because it's not going to change. And next, I'm going to loop. Let me see here. So I'm going to start at my small value, and I'm going to go to my maximum value. And I'm going to increment every time. Now, inside of my for loop, I'm setting a counter to 0 at the first time it runs. And I have an inner loop where I'm going for the length of my crab array. And in here, I'm just incrementing, well, I don't like that pop-up. I'm incrementing my counter every time if I have the absolute value of my, so my current iteration, my current I value, minus that crab. So pretty much I'm checking every position and checking every crab against that position and adding how far it has to go to a counter. And so I'm going to loop through all the possible positions to find the position that has the lowest counter. So and at the end, my least will have the lowest counter that I found, the lowest position value.
Okay.
So I think that was what we had to do, is find the fuel usage for the lowest fuel usage you could come up with.
All right.
So that's a pretty short puzzle, pretty short script here that gave me my answer.
Cool. Does JavaScript not have a max value? So you don't have to use an arbitrary number. Look that up there. Some other languages
They can do
do.
math.maths. Is that what you mean?
Maybe.
Yeah, I could have done that. I
Okay.
could, yeah, I could have easily done that for my array instead of sorting it here. I could have just done math.min and math.maths.
Cool.
Okay. Who wants to go next? Or
Other questions?
I came up with the similar one.
Okay. Let's see yours, Alexi.
All right. Okay.
500,000 instead of 999,000.
you gotta just smash the 9 button, man.
But instead of why 9,000 or whatever that was the number, it's because I submitted one time and I made they were telling me, when you submit and you got an error, they say, oh, it's way too big or it's way too small
Yeah.
or whatever. So I submitted and then it was 480. So it's like, oh, it's way too big. It's like, okay, so it's safe to put 500,000.
Oh, so you had to get the wrong answer first.
Exactly, to submit. I think we can check with infinite or there is something.
You can also do infinity.
Yeah, I think so.
I think they do not have the options that just too low or too high. Like even if it's number different, they say it's too high. They don't have just little high.
Yeah, just add plus one.
On one of the problems,
No,
I
they
actually inputted several wrong answers, and I found out that once you start getting actually close to the answer, they don't tell you if it's high or low anymore. They just say that's not right.
Yeah, that's true.
So if you're
Yeah,
significantly higher, they'll tell you your number's too high. If you're really low, they'll tell you it's too low. But if you're kind of in the range, they just say it's wrong. Because otherwise, you could just
no,
keep
I actually submitted the wrong answer, right? They say it's too high. This exact happened to me, and I just subtracted one and submitted, accepted it. I was so surprised.
But if you
That was
submit too
actually
much,
this.
Then maybe it's not the range, but maybe it's how many times you submit. Maybe after a few times submitting, they just stop telling you.
Yeah, I think so. After reaching to 5-minute length, they just tell you that's not the right answer.
Okay.
I know. That's not the one.
I know too.
I think it was day 15.
You feel me? So I did exactly the same as actually as Scott. So I just looked through the array here. That's how I return it, around number also. And then so for each number, so for let's say the first one is 16. After that, I just go 16 to 1, after 16 to 2, 16 to 0. And when we finish 1 to 16, 1 to 1. And then I just check, is it bigger or not than this? If not, then I save it. Otherwise, I keep fuel. And then at the end, it works. But if we check here, I checked 2 times puzzle length, which luckily it works for the part 1. But for part 2, I realized actually it doesn't work, this solution. So it's a lucky pass. Why? Why does it pass? Is because I think it was I forgot the result, but let's say we needed to meet at number 2. So in this case, it works. But if there were no number 2 in this array, then it wouldn't work.
3.
Yeah, for example, 3 wouldn't work. Then that's how I realized for part 2. So I will show you part 2 after, but then it took me a while. I was like, come on, I just need to increment +1 for part 2. It shouldn't be like, why? And then I realized it's because of this guy. So I'll show you after.
Yeah, and that's why Scott did a range.
Yes, exactly. So that's what I ended up doing for the part 2. It's doing a range, and then he fixed the problem. Yeah. All right.
Cool. It's good.
Stop sharing.
Okay, I will go next then. Okay, so this is part 1. regarding my approach, I also have similar approach to Alexei, I think. Instead of range for part 1, I also did the available values in the list. So for every spot, I calculated the number of fuel needed to move all the carbs into that spot and find the minimum one and submit it. And as Alex mentioned, for part 1, it worked, but for part 2, it wasn't working. But for part 2, I figured out another approach. Rather than giving a range, I figured another approach for part 2. So I will also show that in part 2. But I think rather than range, the one which I came up with was simpler because it was a really small update to my existing part 1 code. Okay, so regarding my code, I have my input here, my sample input separated by commas here, as you can see, and I'm converting them to int here. They have all as int. I think I'm adding them up to sum. Oh, this is just unnecessary, I think. Okay, so I have a dictionary or object, and I'm looping through my input twice. Every time I'm moving twice, every time I'm looping twice, I'm checking if they are not equal, because I don't want to, for example, we have 2 2's in this example. I don't want to count 2 twice, I want to count it once. So in my dictionary, if it's not already in the dictionary, I'm adding the difference, how many fuel it would take to move the second item to the current spot. If it's already there, I am incrementing it by the difference. If they are equal, I'm just continuing. I'm just ignoring the sum. So here at 0 index, I have 16. I have the index of the values too, so I do not confuse duplicate values. At 0 index, I have 16, and the fuels would sum up to 111. At 1 index, I have 1 with 41 fuel. As 2 index, I have 2 with 37. 3 index, I have 0. 4 index, I have 4 with 41, and also 5 index, I have 2 with 37, right? Same values. And yeah, well, just like that.
Yeah.
I'm getting the values.
You're still on your frequency counting kick, huh?
Yeah.
That's good.
But it worked for for part 1 it worked,
worked,
and I made it work for part 2 too.
Nice.
Yeah. Okay, that's it for me. Part 1.
Your admin of code 2021 will be about frequency counting.
Yeah. It's a nice approach, I think. It's a really commonly used approach for problem solving.
All right, I will share mine. You gotta bear with me though, because I don't remember exactly what I did. Let's see. I think that's sideways. I think it's this window. Yep. So 7A. I have both inputs enabled. That's interesting. But anyway, starting out by creating the kind of data structure I want. Typically, what everybody does: get rid of the commas and then make everything in numbers. So instead of a string of string numbers with commas, and then end up with a vector of integers. I get the min and the max. It sounds kind of like what. Yeah, it's got it done. I used a -1 for none. I said, why not? I probably won't do it again in the future, but it's kind of an interesting thing here. And then these fuels set to 0 because fuel is always going to be used. But just going to go a loop. So again, a for loop inside a for loop, like most of your guys' other solutions, and just using a negative. Just number minus position, the number of the crowd minus the potential position, and I'm just going to go through all the possible positions through the range of the min and the max. So this is what Scott did.
Pretty much the same as mine, except for your initial least fuel value 0 and mine's 9.
Yeah.
Okay.
Well, then, because of that, I had to add in
Conditional.
a condition, least fuel equals 0. Yeah. So that's 0, it doesn't stay 0, right? So the first non-zero value becomes the new least fuel amount, and then everything else is kind of compared against that from the non. Well, I could have put in a max value here, which I do later on in my codes, but this is what it was. So anyways, that's it.
This one, part 1 wasn't that hard for me. I think I got this rather quickly.
Yeah, it wasn't too bad.
I think I got it on first try. Didn't really have to redo much of my code.
The first one also, not the part 2.
Yeah, let's go on to part 2.
I thought it was nice after day 6, part 2.
Yeah.
Part 2. All right, so part 2. They don't like to propose solutions because fuel is not linear, right?
So essentially, now for every step they take, it costs 1 more fuel than the step before it.
Right. Somehow, I don't know. Movement's expensive, I guess.
Yeah, they get tired.
The cost is not linear. The cost is polynomial, I guess, right? Because it's you keep on keep adding.
To go 1 step costs 1 fuel, but to go 2 steps costs 1 fuel plus 2 fuel. So it's now 3 fuel to go 2 steps.
The third step costs 3 fuel. The fourth step costs 4 fuel, and that's in addition to the third step and the second step and the first step. So the cost grows pretty quickly.
Yeah, so that's the only change to the question. You still have to find the cheapest position or the lowest amount of fuel to get to the same position.
Right.
So should I share my code for this one?
Or
you
I'll just
go
do it
ahead.
since I already have it open. I figured to switch screens. Let's see. So let's get that out of the way. Beginning starts out pretty much the same. What did I change?
You added a max number now.
So the only thing I think that changed is this one. Yeah, so the calculation of the fuel use is different now. It's if we look at the parentheses and bring it down, there's a lot of litter. Like all this is litter just for casting, because you can't do dividing by without it. But anyways, it's because whenever you do adding of subsequent numbers, like 1 to let's say 5, right? You're adding 1, 2, 3, 4, and 5. This was actually I think early on, one of the things that Francis Bacon, I think, was famous for quote unquote discovering, but that you can actually, or the story it has that he solved the problem this way, and the math teacher was like, "What? You can't do it like that." And then he proved it worked, and then whatever, his math teacher was stupid. But that's what was known at that point. But what he had shown is that when you have 1 through 5, you can actually just cut it in half, take the minimum and the maximum, add them together, you get 6. Get the second one, 4 plus 2, you get 6. Get the middle one, 3 plus 3, you get 6. You can just take a half of your thing, you can take an entire thing, as long as they're all subsequent, right? As long as they're all contiguous, you can sort them, cut it in half, and or basically cut in half to get the length, but then just take the maximum and the minimum to get the number that you need to multiply by the length of the half, right? So let's say 10, for example. It's 1 plus 10 is 11. And then you go inwards in. 9 plus 2 is 11, and then you go inwards. 3 plus 8 is 11. 4 plus 7 is 11. 5 plus 6 is 11. And so essentially you have a bunch of 11s. And how many 11s you have is the calculation. It's usually about half, or it's half depending whether it's even or odd, right? And to take care of even or odd, to get a ceiling of that number, I add 1 to it, so that even if it's the wrong one, you can at least push it up to the right one. If you get a half, it gets pulled up to a whole, and then divide it by 2 to get the half, and then multiply it by the actual distribution, and then I get the amount of fuel used. And so that's how you add, or that's one way to add up contiguous numbers quickly. All right. That's the only thing that changes, was to calculate the amount of fuel used.
That's a clever shortcut. All right.
Yay, Francis Bacon. Anyway. Next. I think it was bacon. It better be bacon, or the whole story's wrong. We'll see.
I guess
How
since
long
my
it
part
is.
one was so similar to yours, I guess I'll share mine now.
Sure.
Let's see. That's still my part one. Let's go to my part two. So part two, I kept everything exactly the same, except in order to get my total count, instead of using Francis Bacon's power, I just added another for loop, just to loop until we got to that position. We're going to increase the inner counter by 1 each time I take a step. So that's all. I'm just increasing the fuel cost for every position that he has to move to get to the position that I'm currently checking.
Yep.
And that's all, just one extra for loop. Cool. Yep. That's it.
That's it.
So still essentially the same as Alex, except I'm not using that clever little shortcut to get the increased counter. I just have another loop.
Just
So
redo
loops
it.
and loops and loops.
Yeah. Okay. Alexi, the JavaScript.
Share my screen, continue. Okay. I haven't been clever enough also because I did exactly the same as Scott. So, but this time I came up with the min and max.
Okay. See,
Otherwise it wouldn't work. So it's exactly the same. I just put couple of extra zeros.
Nice.
Just in case.
Yeah, just in case.
Was that also trial and error by submitting a wrong answer and it telling you it's too big?
I don't remember. I think automatically I just increased like
By instinct.
yeah, I just put 2 more zero.
500 million should be.
So then this time, yeah, instead of doing like if we look at part 1, you know, 0 and then the length of puzzle. So I just switch to what you actually did, like to get the min and the max. And then, yeah, I just added extra steps, which is +1 all the time. Then added it to the potential fuel. And then actually it's exactly the same as before that one. That's
Well, it's
it.
good you increased your number because my final answer was 95 million something. Did I increase mine too?
So how long is it taking you to run this code? I assume it's taking you quite a while, right?
No, actually, it's pretty quick, huh? What I remember. Of course.
This is
Mine took about 1 second.
Yeah, with just numbers, it shouldn't take too long.
It does take some time.
Oh, it does take some time. Okay, so.
Yeah, it does take some time.
all right.
Yeah, it took at least like 2 seconds, I guess. Yeah, it's like about 6 seconds, 6-7 seconds. Yeah. So it's quite some time. Yeah, I think this extra, as you said, it could be saved.
Mine's maybe 2 seconds.
But you're well within the 15 allotted seconds.
Yeah.
According to the about screen on
Yeah.
the admin code, right? It's something like 15 seconds on a
10-year-old
computer.
Yeah. That's it.
Okay. So Python, right?
Yeah.
Okay. So I'm still with my count approach, but I realized I had to change my method of calculating the sum, right? So there is a method called factorial. I thought it's a similar approach to factorial, but instead we need to count the sums, right? For if the numbers are 1 to 5, we need to count the sum from 1 to 5, right? We need to count the range.
Right.
Of sum of the range. So I created one method called summutate. I don't know if it's an even word, but summutate, it basically will sum up the range and returns the value
Oh, that's the bacon formula.
Yes, I think I need to search this one. I searched how to calculate the factorial. Then I realized it's not factorial, it's a sum. So
Yeah.
there is an
Factorial
approach
is
for that too.
multiplication.
Yeah, multiplication. So it's the same code basically,
Mhm.
and I just have a different way of summing the difference. But even so, now the interesting part is you guys are counting the range, but I'm still not counting the range. I'm just counting the available spots in my array. Then it hit me that, for example, let's take the part 1, the sample. I have the minimum value is spot number 2 with the fuels are 37, right?
Mm-hmm.
And the next one is spot number 1 with the fuel amount of 41. So I realized that if I have a spot which requires even less fuel than that, it needs to be between those values. So 37 and 41, the spot needs to be closer to 2 in order to be lower than that. It needs to be, if let's say now the spot is 1, but if the spot with the next least fuel was, let's say 5, my least fuel number needs to be between 5 and 2 in order for this to have a. Anyways, this was my idea and I want to test it in my spot, and there is an interesting output. So if I run my code, so I basically calculated the sums as a dictionary and I sorted my dictionary with the fuels cost for each spot. So I have the least one first, and etc. So this is my oldest spot with their fuels required, and it starts here. So I have my list in this array is 459 spot with this value, right? And the second least one is 457 with this one. So I, based on my thesis, the next, if there is any spot which is less than 459, it needs to be between those two. So there's only one number between those two, 457 and 459. There was the 458, right? And I added 458 to my input to test.
Mm-hmm.
Yeah, to test that hypothesis. And it was true, it worked. There was only one range.
Mm.
So if I run my code, yeah, so 458 is the least fuel one. So I just gave that input.
Okay, so given, so it's almost like you average out the leasts,
Yeah, basically, yes.
which would work.
I'm not sure.
As the number is linear.
Yeah, can we test someone else's input just in case, Alexi?
You want my input?
Yeah. To see if it's also a similar scenario.
I'll send it to you.
Discord. Okay.
How can I
You send it on Discord?
I want to, but oh, let me just try to send you the file directly. Second. File, and then
I wonder if like coordinating crabs is like herding cats. Because I don't think the crabs are just gonna sit there and wait like, all right, I'll give you a couple seconds to calculate this. And then after you calculate it, it's like, all right, I want everybody in this spot. And then just having them all like, okay, all like, how many are like 1,000 crabs just decided, oh, okay.
Well, they're in their submarines. So maybe there's like one chief crab that can control all the other submarines.
And then like, how do they all like 1,000 of them go to one spot?
Well, they don't have to be in one spot. They just have to be vertically aligned. So they're just like in a line as a.
So like, one of them is like just below the surface.
What was the whole point? They were going to blast a hole in something, right?
Yeah, but they have to concentrate all the power at the same time.
right.
Actually, instead of doing, I'm thinking instead of doing a third for loop inside, as we know it's +1. So if, for example, it was part 1, it was 41, we know it would be an extra 41 for the part 2.
So I have my Alexis.
At part 1, the least fuel was 41, let's say. Then part 2 was just to add +1 for each fuel used. So then it should be 82, right?
It's not +1.
Because it's +1 for each position that each crab has to move.
Yeah, it's +1 for every movement they make. So if a crab had to move 5 positions, it's +1, +1, +1, +1, +1. But it's for everything beyond 1 position. Actually, no, it's not even that, because it's only +1 for the first or the second position. Third position is +2. Fourth position is +3. Fifth position +4, and so on.
I think for Alexis, the minimum range was already inside the array. So 481. Is that your answer, Alexis?
My answer is 982, 31, 31, 64, 7.
Oh, it's a
That's
second.
correct.
Yeah, so it's already inside the array because the next one is 480.
Oh, okay, so he's got 2 of them in there.
Yeah, and they are next to each other, like they are sequence. 481 and 481. Next is 480. So I'm thinking it's already 481.
The same fuel costs for also?
2 positions.
Yeah,
The same fuel costs.
index 290 has 481 and index 645 has 481. And both of them are same fuel.
Interesting.
So it must be the position in the middle, right?
Yeah.
+1, yes, it's con +1, sorry. Yeah. Okay, no, what I said earlier, it doesn't work.
So that's my approach. Any questions?
No.
That's cool.
Yeah.
It's cool to see,
Okay.
since me, Alexi, and Alex all did it quite similar ways. It's interesting to see a completely different approach.
I was assuming if the range was not like 1 or 2 digit, I was going to take or slice that range and put it inside the same function one more time. But since it was only 1 digit difference, I just gave it a shot.
All right, that's day
All right.
7.
Cool, yeah.
Yes, we'll meet again on Monday to talk about days 18, 19, and 20, and answers for day 8.
Yeah.
What was day 8? I already forget last week.
The digits, we have to.
Oh, pretty much digital displays.
Yeah.
Yeah, it was interesting too.
Oh, okay. This
7-segment LED display.
This one is a very procedural one. It was interesting.
Yeah.
Definitely needed paper
Right.
for that one.
So we'll go over that on Monday. So thanks for popping in. We'll catch you guys on Monday.
Okay. Have a good weekend.
Later, everyone.
Bye.